Well, it's good. It's good. Blessing, I dropped a message that you should take us on the recap of last session so that those that were not here will also get to understand what we've been doing. I'm currently stuck somewhere and I'm unable to join us.
Oh, okay. Okay, that's fine.
Yeah. But then when is supposed to take today's session? I wonder why he's not here yet. But while we are waiting for others, I would love you to give us a recap of last session. But before then, please, Dixon's hand is up. Dixon, please speak. Dixon, your hand is up. Please, you can unmute your mic now and talk. Okay, perhaps it was a mistake. All right, that's okay. So, Blessing, please give us a recap of last session. Thank you.
Okay. Hi, everybody. Okay, Dixon said it's a mistake.
Okay, good.
Yeah. Hi, everyone. So, our last class was about pointers, and we looked at how to declare a pointer and some other areas of pointers. So, maybe I don't know, how many of us were in the class, the previous class? Please, if you're in the previous class, can you just give us a wave of hand? Just put your hands up. Let's see. Okay, Dixon was in the previous class. Who else? Okay, Justice, yes. Who else? Okay, so we have Dixon and is it Justin or Justice? Okay, Justice, can you please unmute your mic and just give us a quick recap of what was the main point you left with from last week's class?
Okay. Good evening, Blessing. Good evening, everyone.
Good evening, Justice.
Yeah. From last class, I was able to understand the pointers very well, especially the use of the asterisks and how to dereference a number, like reassign a number through the pointers or reassign a value through pointers. So the last session made it clear to me very well.
Okay, awesome. All right, awesome. Well done. Dixon, please tell us something you also left with from last class.
Okay, good evening, everybody.
Good evening, Dixon.
Yeah.
Hello, Dixon.
I was actually hello, can you hear me?
Yes, we can hear you now.
Yeah, I said from our last class, I was able to know the difference between a pointer and a normal variable. A pointer variable holds the address or location of another variable, and a pointer to a variable must have the same data type with the variable it's pointing to. Also, I learned that pointers and arrays are their synonymous, in the sense that the name of an array can be used to reference a memory location. Also, a pointer can be used to hold a memory as well. And we're also taught how to use pointers to look through and also we're taught how to use pointers to look through array. Thank you very much.
Okay, awesome. Well done, Dixon. That was quite detailed. So basically, those were the things we did on pointers. Mr. David, I think this is a recap already. We're done with the recap. Is Mr. David close? Okay, I guess he's still on the road, on his way home or whatever. All right, so today's session is actually supposed to be on array, right? So before Mr. UM comes to start the session on arrays, how many of us have like prior knowledge on arrays and wouldn't mind sharing with the house before the class starts? If you have a prior knowledge on array that you'd like to share with us, can you please indicate by raising up your hands? Are you still hearing me? Or is my internet affecting my... Hello, everybody? Okay, so I'm asking, is there anybody who has a prior knowledge on arrays and would like to share with us? Okay. Obviously, nobody is willing to share with us.
Okay, hello.
Hello? Yeah? Okay, Dixon, you want to share with us? Awesome. We can hear you. Hi, Dixon. Okay. All right. So let me just introduce the topic, array. Before
I want to share a little that I know.
Okay. Awesome. Awesome.
Okay. So arrays are derived data types. What I mean, we have sorry, my baby is here. That's why.
It's fine.
My arrays are derived data types or advanced data types. So arrays, they are data types that are used to hold elements of the same data type. Now, when I mean we have a derived data types are like a data structure. They are data structure, but they are static data structures, not dynamic data structures. They are used to hold elements of the same type. For instance, when we have a group of data that we want to store in our memory, at times we have to start declaring more than one name for those variables. Let's say, for instance, we want to save about, let's say, data for about 10 different people. So now we know, let's say we want to get the age of 10 different people. If we decide to start using one name or one variable for one data, one variable for one age, it's like a waste of time. So that's where the derived data type came in, which is an array. An array can be used to hold those 10 data all in one name. It's just like you're declaring a variable that will hold 10 different, depending on the size you have declared for that array. You're using just one name to reference those 10 data. We're using 10, for instance. So now, if you want to collect the data of 10 different people, let's say the age, so you can use just one name to hold those 10 names. Then now an array can be declared using the data, there is the following syntax. the data type, then space, the array name, the name you want to give to an array. An array can be declared without initialization, as well as an array can be declared with initialization or with data. So an array is not only meant for integers or floats. We also have an array of character, which is in C referred to as strings. Arrays, to access the different elements in an array, we use what we call the index of the array. Every element in an array has the index, and the index starts from 0. So if we are to say, for instance, we are saving a data of 10 different, let's say the age of 10 different people, and we are storing it in an array. The first element inside that array will have an index of 0, and the last element, which is supposed to be the 10th element in the array, yes, which is the 10th element in the array, will have an index of 9. Accessing them, you can traverse an array. Traversing means you can add to an array, remove from an array. You can modify the content of an array, specifying the index, and as well perform other functions with array. Now, an array name sounds more or less like this. An array could as well, the name of an array could as well act as a pointer. When you're declaring an array or when you're assigning an array to a pointer, you don't need to specify the ampersand or the address of symbol. I think that is what I know about array for now. Thank you very much.
Okay, awesome. Thank you so much, Dixon. That was quite detailed. Thank you so much. David just dropped a message on the chat box. He said that he's inactive at the moment and he's currently stuck somewhere. That the person who's supposed to take the class is not available. That we should continue. So Dixon is saying, Blessing and Dixon, please continue. Thank you. I'll be going now. Please take care of the class. I will talk to you tomorrow. All right. So let's make this work, right? All right. So well done, Dixon. So let me share something. I don't know. I'm supposed to have a PowerPoint on this. Okay, let me just go ahead and share what I know about arrays. All right. So, like he already said, an array is a variable. It's a kind of variable that stores multiple data, in the sense that you don't, for example, you have you're a teacher and then you have 10 students, and then you need to record their scores. Instead of picking each score and recording separately, you can just have a name score, and then that's the variable score, and then store everything using different index. That's from 0 to, if it's 10 students, from 0 to 9. If it's 20 students, from 0 to 19. So basically, now if you've taken notes, when ALS gives us tasks, they start from 0. Now that's the same format that an array takes. That's the index of an array. It always starts from 0. So let's quickly, let me share my programming compiler and let's see what we can do. First of all, let's all remember that this class is not a planned. The way it is going is not planned. So I'll need every one of us to contribute what we can contribute to make it worthwhile. Okay. So do I have you guys? Do I have your support to make it worthwhile? Seems like I'm talking.
Yes.
Nobody here. Okay. All right. Okay. So let's run through some examples. I got a couple of questions, so I'll post each one question on the platform so that we can. That's on the chat box. Let me quickly do that. Okay, I posted this, but before we do this, let's look at how an array can be declared. So we can declare an array in different ways, just as Dixon had earlier mentioned. Let's see. Okay, so let's declare an array. Int array. Oh, okay. Int array. Now we can put we can put the number of elements that would be in our array. So let's assume we want to put 5 elements in our array. We can go ahead and declare it like this, right? Then if we want to go ahead to share the elements individually, then we use a curly brace, and then we put in the element. So let's say we have 67, 12, 29, and 15. Okay, no, that's not 5, yeah? 23. Okay. So let's assume these are the sorry. This is supposed to come up here. Okay, so we can declare and assign values like this, right? Then we can also do it one after the other, in the sense that we have our array here, and then we want to come down. I'm not quite sure if I still remember how this is done, but let's say, please, if I'm getting it wrong, someone should draw my attention to it. Okay? So 0, I say 0 is equal to 23. Array one is equal to 12. Then array 2 is equal to, so like that, we can actually list out the elements of the array like this, right? And just mention all of them. If our array is supposed to have 5, let's assume our array is supposed to have 5, we can list out all the elements like this. So that's another way that this can be done. Can you all hear me?
Of course, we can hear you.
Okay. So we can actually list array one after the other all the way down, and make sure we have at least 5 elements, right? Yeah. So that's another way of assigning or declaring your variable. Okay. Then let's take a look at the question on the chat box. The question says, write a C program to find the sum of all elements in an array. Okay. Now, for us to find, let me copy the question and paste on my. Okay. Okay. So let's assume, instead of just putting the sum of all, because if we were to do the sum of all elements in an array, and it's not clearly defined what we're adding. They're not giving us a specific figure or the elements of this particular array. So in this case, we might need to allocate memory using the malloc, right? Because we don't know the number of elements, neither do we know the elements themselves. So let's solve this. Let's solve this together. So we have int main and so first of all, we want to declare the number of elements. We want to declare a variable name for the number of elements, right? So let's say int num, right? And then we want to declare the sum, right? We might also want to declare the coming. Okay. Sorry, my so many tabs are open, so I'm trying to find something. Okay, so we also have the name of the array. So let's name it array, right? Sorry. Okay. And for this sum, let's initialize it to 0. Okay. And so as we go ahead, when we discover any, okay, because it's an array, we also want to declare I so that we can use to iterate through it. So the first thing we want to do, because we want our user to be able to put the number, so this, what we're creating is like a program where the user can input the number of elements they want. So let's go print f, and then we're going to prompt the user to input the value they want to print. So we're going to say enter the number of elements. Okay, so we're asking the user to enter the number of elements. And when the user enters the number of elements, we want to save it. And we would like to save it in, okay, using %d. I would save it at the address number, num. So we have saved whatever the user inputs, we would save it there. Then afterwards, we want to declare, because we want space to be able to take in the, able to take in the elements. So we're going to have to declare malloc, okay? So, and our malloc would usually have to be the pointer. And remember when Dixon was explaining, he mentioned that the name of the array can also stand as a pointer. So even while declaring, sorry, I didn't put that, sorry. So it is a pointer to whatever would be declared, right? So when we're coming down here to allocate memory, we would now say array is equal to malloc. What are we allocating? What's the space we're allocating? We're allocating the number times the size of, what kind of variable is it? Size of int. So this is an integer. So we're allocating the number. So if the user inputs 5, for example, it will be 5 times the size of integer. If the user puts 3, it will be 3 times the size of integer. that would be allocated here. Okay? So far, is there anybody who's confused? Am I carrying everybody along?
Yes, we are along.
Okay, all right, so let's go ahead. Now, we have declared this. Now, first, another thing we would also, that's very important that we, is that we need to check if the space is not available. If the space for this memory allocation we're trying to do, if the space is not available, we need to give a prompt for it to end the program straight up, right? So that is why we would now need to say, use the if statement. If, open brackets, array is equal to null, if the array is equal to null, then we're asking the program to print, to tell us that memory was not allocated. So we're asking the program to tell us that memory was not allocated, and then it returns 1. Okay? But then, in a situation where the memory is available, so that means our program should go ahead. If the memory we have requested for, if it's available, that means our program should go ahead. And what would it go ahead to do? It will go ahead to print. It's a printf. Remember here we scanned the number of elements. Now this time around we want to ask them to impute the element. By now we have allocated space. So let the user impute the element and let it be imputed where it should be. That's in the space that has been created. So we'll ask them to impute elements. Okay, before this scanf, because it's going to be, the user is going to be imputing multiple elements. Because the user will be imputing multiple elements, then we need to use the for loop to be able to get each of them one after the other and put them in the right place, right? So our for loop will say, if i equal to 0, what are we going to do? We're going to be doing I less than n. Num, sorry, we declared it as num. Okay, and then we increment I, right? So after this, the next we want to do is go back to our scanf, and then we want to scan each of the elements of the array. So let's go ahead and do that. %d. And then what are we scanning? We're scanning the array. That's each element of the array. So array, and then I. Okay, so this is what we're scanning, right? So that means for each element that the user would impute, the scanf would save it on that's under array, but the space that has been allocated for each of the elements. Okay? So after doing this, that is where we now, because now that we have saved it, as we're saving it, the next thing we want to do is to sum it up. Remember, our question says we should add, right? So we want to sum it up, and after summing, before we print. So let's go ahead and sum. Sum is equal to sum plus I, right? So sum is equal to sum plus I. And then, okay, for my for loop, I didn't create a brace. I always like to create braces. I know in some cases it can be negligible, but I think it's safer for me to just create a brace. So here we go. So now this time around, I have to close this brace before I print. So I will print each of the, printf.
Hello, Blessing.
Yeah, I can hear you. Did I break at some
Are
point?
you printing the sum? Are you printing the sum, or
Yes.
you're trying to get the sum?
Yes, I want to print the sum so that you can see.
If you're trying to get the sum, then the sum is supposed to be sum plus the array itself, not the iterator.
What did I put there? Sorry, I'm coming. Yes.
It's supposed to be sum equal to sum plus
Sorry.
array.
Array,
Aye.
then the iterator in the box. Sorry, I skipped that. Thank you. The iterator in the box. Sorry, I skipped that. Aha. So that means each element of the iterator. Thank you so much for that reminder. Okay, so now the next thing we want to do is now to print the sum of all elements. Okay, so let's do that. The sum of all elements and we put our %d, and then we come here, and then sum is what we're now going to display, right? Yeah, so let's run it and see. Okay, we have some errors. Okay, we didn't add our standard library, which is where malloc is located, right?
The header file.
Yes. Please, if you notice any other error that I haven't taken note of, sorry, just bring my attention to it. So let me run it again and see what is left. So line 30. Oh, I have 2 braces.
Yes.
Okay, so it says we should enter our element. So let's assume we want to put the element, 4 elements, right? Let me run this again. 4. Then it will ask us to put in I should have made this better. Okay, let me make this look a bit neater. Okay, so let's go again. Okay, so enter the number of elements, which is 4. Then 23. 12, 9, and 42. Okay, so the sum of all the elements is 86. So we have succeeded in creating a program that helps us sum up the number of elements. Is there anyone who didn't understand what we did here? Is there anyone who didn't understand what we did? If you have any questions, I think it's a good time to ask. Hello? Hello? No questions? Okay, if there are no questions, then I would be looking for names. I'll be checking among the names and sharing some questions to people to solve. Is that okay? Is that okay? Hi, everybody. Okay, all right. So Camillus put up his hand. Camillus, can you go ahead? Yeah.
I have questions to ask.
Okay. All right.
Though you did well by simplifying it, but what I want to ask is that is there no way you can write a particular program that will just do this stuff? I think you just simplify everything.
Okay, you mean a simpler program without using array?
No, I mean a simpler program of array, but not too lengthy like this.
Okay.
Or this just a deck format. No, I'm just asking. I want to know.
Okay.
No, but I love your the way you break everything down.
Okay. All right. So, sometimes when the question comes to you, it's the way you're able to interpret it that, gives you a way to solve it. You get. So there might be an easier way, but I have not thought of it. And I believe that probably the more we practice, the more we code, the more we find out ways to make it easier. Do you understand what I'm trying to say?
Yes.
Yes. So there might be easier ways to actually solve this, but it hasn't come to mind. So that's why the more we practice, the more, we'll get to see ways and see things that are negligible, things we can actually take off the code to make it look smaller.
It's okay.
All right. Thank you so much for your question. Thank you. Any other person? Hi. Okay, so let me share some questions on the chat box and see if there will be people who will be generous enough to help us solve them. Okay. So, yeah, Camillus, go ahead. Camillus, your hand is still up.
Oh, sorry, it's a mistake. Sorry.
Oh, okay. Well done. All right then. Dixon. Hi, Dixon. Is Dixon still here?
Yes.
Okay.
I'm having network issues. Sorry.
Oh, okay. So I was going to check on the chat, on the call, if there are people who would be generous enough to pick one question. And
you wanted to ask a question, or?
Okay, yes, go ahead.
Okay, I wanted to ask a question. Sorry.
Okay. All right.
No, it's just like a teaser. At least it's going to help other people.
Okay.
From your code.
Okay.
From your code, you notice that we're using an array.
Yeah.
Why did we now introduce? Remember, array is for static, as in when you're declaring an array, you're declaring a static memory locator. So what was the reason why we added the malloc? That's my question.
Okay. Now in this situation, right? The space it's not defined the memory that is needed for this. So we need to be able to allocate in a situation where you are given the elements of your array and all of that. You would be able to work without declaring malloc or without allocating space for this, right? But because we do not know the space to be allocated, it's based on whatever the user imputes. That is why malloc has come to play here. I don't know if that answers your question. But if there's something you want to buttress, it would be great to do that. Hi, Dixon.
Yes.
Okay. Okay. Is there something you want to add up?
Okay.
Okay.
Thank you.
All right. Okay. All right, Camillus, your hands are still up.
Sorry, I don't mind this abeg.
Okay.
Yes, I can hear you. Yeah, my network is bad, so I can't hear everything. But if there's anything I want to add,
Yes.
you've already done justice to it.
Oh, okay. Thank you. Okay. There's.
You've
I
already
can
done
see.
justice to the topic, so I don't know if I really have anything to add.
Okay. I can see one. Nwoke Onyinye. Hi. Are you with us here? Can you hear me?
Yes, I can. Hello.
Okay. So I don't know. Do you have any questions, or would you want to help us out with one task?
Don't really understand it, to be honest with you.
Okay. What aspect got you confused?
The part where you wrote memory not allocated, print F.
Okay. Did you
From
understand
that
where we are?
part,
Do you understand where we allocated memory?
no.
Okay. Okay. I guess you're new to malloc too, right?
Yes.
Okay. So that means maybe subsequent classes where we'll do malloc, you can partake in that. But aside from that, if I think we did malloc some weeks back, so I'm not sure.
I wasn't in the class. I didn't attend the class.
Okay. Now, if you have any, maybe we would have a personal session or with
It's
David
okay.
or something like
It's
that.
okay. Thank you very much.
Please post me on WhatsApp so that we can see how we can work on that, right?
It's okay. Thank you very
Okay,
much.
but you're welcome. But let me still quickly run down what happens with malloc. Just a brief summary,
Okay, thank you.
so that we don't leave anybody behind.
Okay, thank you.
Okay. So this is what happens. In a situation, malloc is used. The meaning of malloc is memory allocation, right? So, in a situation where you need to allocate memory, especially when you don't know what will be put there, so you might need to allocate memory for whatever would be put there subsequently, right? So that's what we use malloc for, memory allocation. Now, when we declare a normal variable, it is stored in a place in our memory called the stack memory. But then when you personally, intentionally use malloc, right, something happens. It means you are requesting for a space. You are personally requesting that space be created, and it would no longer be created in the stack memory because you do not have control over the stack memory. It will now be created in the heap memory. Now, in my code, there was something I left out, and I was hoping someone would draw my attention to it. And eventually, I also forgot to bring it up. So when you create a memory, it is important that you also free.
You did not free the memory.
I didn't free the memory.
You didn't free the memory.
Yes. So, but let me explain first before I go back to freeing the memory. So, when you allocate memory, what you're trying to say is that put it in a place where it can easily be manipulated. I can easily create it and I can delete it. I can create the free the space. You understand? And for you to be able to create or for you to be able to allocate memory, you use the malloc function. And the syntax is your malloc, then the number of space. That's the number of this thing you want to put inside. Then the size of whatever variable it is. So if it's int, you use size of int. If it is a character, you use size of char. Okay? If it's float, you use size of float. So let's say because it's int takes 4 bytes, right? So because int takes 4 bytes, the num here times 4 bytes. You get? It's just like saying my shoe, I have a pair of shoe, right? So if I have 5 pair of shoes, it simply means there are 10 legs, like 10 individual shoes, right? So that's the same thing that happens when you do malloc. So because one int is 4 bytes, it will automatically create 4 times. Okay, like this example we did, the user imputed 4 elements. So 4 is the num, right? So that num is now multiplied by the size of an integer. An integer is 4 bytes. So 4 times 4, which is 16. So automatically you have created space for space of 16 bytes. Now, but you're not always sure if your operating system or your system has enough memory. That is why we use this if statement here. So in a situation where array is null, that means there's no space for it. Please just tell me that memory not allocated and then end my program for me. But in a situation where the space is enough and it will be enough to run this program, then you go ahead and then ask the user to put in the elements. So the user would now put in the elements. And after they have put in the element, because there are different numbers, it's not just one. So you cannot pack them and just go and put them randomly. You have to take them one after the other based on their index number. So the first thing it will take, because I is equal to 0 from the beginning, I is equal to 0 means the first element. Remember, Jackson explained that the first element is 0. So I is equal to 0 means it will start from the first element, which is 23. So 23 would be in that location of the index number 0, right? So when it goes, it will bring it down here and put it in, that's the scanf would now save it under the index number 0. Then the sum would be calculated. Then it will now go back. This time around, it's now 2, right? So it will do the same thing. It will now add the 2 to whatever is here. And that's how it goes until it finishes the whole process of adding. So this has allocated space for each of them, has put them in their right space, and also summed the total. That's basically what happened in this program. I don't know if you understand now.
Yeah, to some extent I do. Maybe I'll go over it.
Okay, that's awesome.
Thank you.
All right, you're welcome. You're welcome. So, Justice Obasi, do you understand what we did so far?
Yes, I understand this.
Okay, awesome. Then Musa Jamil. I just want to be sure that we're all on the same page. Musa Jamil, are you still with us? Uh-oh, he's not responding. Okay, what of Blessing Akibe? Oh, Blessed, sorry. Blessed Akibe. Okay. Wilfred?
Hello, good evening. I understand. I just joined actually.
Okay, welcome. Okay, so
Yeah,
do you understand what we've done so far, or you need an explanation?
yeah, I get the gist.
Okay, all right, awesome. So I guess most of us have understood the whole concept. We have a few questions that I posted on the chat box. I don't know who is bold enough to pick one and help us solve it. Come on, we're
I can't see the question. I just joined.
Okay, let me post this again. We're software engineers. Let's. It's not a problem if you make mistakes. Okay, so I just posted them again. So I want some people to just pick them up and let's just do this. Someone pick a task and then solve for us. Okay, Camillus put up his hand. Camillus, is that another mistake?
Let's see. I don't know this my hand, but it's a miss.
Okay, I think David is back. Hi, David.
Okay, hi, Blessing. No, I have been around all this while. I was just in the background, getting the concept, and this is nice. Please, I'm very happy for this. I'm proud of you.
Oh, thank you. Well, you left me alone, sir. You left me on my own.
No, I didn't leave you. No, I did not leave you. I've been in the background all this while. So I just thought I should say something now. I'm very happy, actually.
Right.
Yeah, the person who was supposed to handle this class, I've not been able to reach them. But seeing how you're taking it, it's almost as if you prepared for the class. So thank you very much.
I was actually studying with him, but I think his battery, he reached out to me and told me that his battery was down. Like, I think he said 4%. So probably while we were talking, it went off. While we were chatting, it went off.
Okay, great. Okay, great. Also, I wanted to say, people may not answer to your questions. So I would say you should pick anybody in the group here and say we should solve it.
Okay, I think Wilfred was about to pick one.
Okay, please go on. I will just sit back and enjoy the whole show because I'm enjoying it.
I think Wilfred was about to pick one. Wilfred, am I correct? Hi, Wilfred.
Yeah, I just wanted to go through the question.
Okay, so you want to give it a shot?
Not yet.
Don't worry, we are all here to support each other. You can actually pick it up and then anywhere you need ideas, we're all going to share ideas. Hi, Justice. Hello, Justice.
Yes, I'm here.
Okay, you want to pick one of the questions? That's right. You know, we get better by practicing.
Maybe you can give us one more example, then I'll pick up one.
Okay, one more example. Okay. Let me go and check there then. Oh, Mr. David, you want to help us with one example?
I'm not sure he's back.
Okay. He actually came back and he spoke with us a few minutes ago. Okay, I'm going through. Let me see which one should I solve now. Okay, let me pick a question then. I'm also going through the questions to be sure I understand it before. Please give me a minute. Okay, I think I figured out a way we could actually tweak this particular code without using malloc. Okay, so I want to try it out and see. Are you all with me?
I'm with you.
Hello? Yes, so I want to see how I can tweak this code without us using malloc. Right?
Yes. Yes.
Okay, and that would make it a lot easier. Okay, so in this situation, if we want to do that, it means we'll just pick a we don't want our user to exceed. So our array, we can decide that our array should not exceed 10 elements. Right? Oh, okay. Okay, so let's see. All right, so now let's input the number of elements. Let me see. Oh, so it's saying segmentation fault. What could be the problem?
Hello?
Yeah, I can hear you. I can hear you.
Hello?
Yeah, I can hear you, Dixon. Okay, we don't need to free.
Okay. Now we're not using malloc, and you're using the free.
Yes, I just realized. We're not using free.
Yes, because we're not using malloc.
Yes. Okay, so let's see. Yes, so we've been able to do it without using malloc. I think this answers who asked the question, Camilos, right? I think Camilos asked the question how we can do this, how we can do the same code without having to use up so much space, write so much code, right?
Yes.
Yes. So this is it. We've been able to take off malloc from it and then solve it in a way that so for you not to use malloc, you must first of all be able to allocate the number of that's the space that should be used up. That should be allocated for the array. Okay. So that's it. So I think we can count this as a second task then. Okay, so anybody ready to give it a shot? All right, probably we can go with the questions. Maybe I should give the questions to Mr. David and see if he puts it up, if he can put it up on our, so we can have more
Madam
time
Blessing.
Yeah? Yeah, I'm listening, Dixon.
Hello.
Yeah, I can hear you.
Hello.
Hi, Dixon, can you hear me?
Okay. I wanted to just say something like, yes, I can hear you.
Okay.
Like for instance, if a person should put more than 10, as in concerning this code you've written now,
yes.
If somebody should impute an array of numbers more than 10, it's going to give us a segmentation fault. What if we check? What if we check, like using an if statement to check if the first array range is above 10, then it gives us a message. If not, it continues with the input of the different data.
Beautiful. That's lovely.
Because we've hard coded and we've said that we want it to be, it should be more than 10.
Yes.
So now we've not checked if the imputed value is more than 10.
Yes.
I don't know if you understand.
That's totally true. Yes. So we can decide to write the code in a way that if the user imputes a number that is more than 10, our code should be able to tell the person that it's an invalid element, or you cannot proceed with this element. You understand? Or basically that. And then if you like, you can also, in your printf statement, instead of saying enter the number of elements, you can say enter number of elements not more than 10. Or enter number of elements from 1 to 10. You can do that. Do you understand? So we can actually do this, and then we can still use the if statement. So we say if the user imputes that if num is greater than 10, right? If it's greater than 10, then what should it say? It should, let's see. So if it's more than 10, it should tell the user to invalid or invalid. Okay, so this is it. Let's see. So let's assume the person decides to put 13. You can see. Okay, why is it still giving us this? Okay, that means it needs to.
It's either we break out or we exit.
Yes, or okay, so we
Either
can
we
do
break out.
return 1, right? Yeah. Or let's just use the exit. Let's run this and then see how we can also use exit. Okay, so that's for return in a situation where we want to return. But then let's try the exit function. I'm sorry. A function, right? I think. I'm not very familiar with using this exit function. Dixon, is there something I'm missing out? I'm not really familiar with using the exit. Oh, Dixon was out. Camillus, you want to say something? Or is still your hand? Your hand is on the default setting of being raised. Mr. David, is there something I'm missing out?
I think the exit should be -1.
Okay.
Maybe 1.
Okay, there should be a statement in the exit, right? I've never used exit before.
Yes.
Okay.
Exit 1.
Okay. The same, that's inside the bracket, right?
Yeah.
Hello?
1 or -1? Yeah.
Hello?
Yes, I can hear you.
Yes. There should be a statement in the exit.
Yes.
Zero
maybe
is
one
for
or one.
successful exit.
Then 1.
One
Okay.
is for an error in your exit, an error costing the exit.
Okay, so let's do this then. Let's use 1. Let's use 1 since it's an error. So let's go. All right, so if the person puts 12, okay, so that means the same thing return does is the same thing exit does, right? Am I correct?
No, not actually.
Okay.
Yeah.
Please, can you educate us on that?
Duxin.
Okay.
Anybody, Wilfred, you can also educate us on that if you.
Okay. What the exit does, the difference between exit and return.
Yeah.
If, for instance,
Hello.
okay, Sir Wilfred, good evening, sir.
Good evening, my chief.
Okay, this is what the exit does. The exit and the return, what the difference actually is that when you do a return, your return returns a value.
Okay.
When you do a return, the return returns a value to a next function that actually has called. If, for instance, you have more than 2 functions, and let's say, for instance, your main function and maybe a sub function you have written. If your custom function returns a value, that value is now passed to any variable that is calling that function. Yeah.
Okay.
So that's why you can as well now check, is this function, did it return 0? If it returns 0, do this. If it does not return 0. But when you use an exit halts your program automatically. It does not go back to the main. It does not. Yes, it goes back to your system call, as in your system itself. If, for instance, you do, you run an exit, and once it exits, it does not return any value to your system, to your function. Rather, it goes back to your system CLI directly.
Okay. Awesome. Thank you so much. Thank you so much. Yeah. Thank you so much. I've learned something. I've never used the exits. Neither have I. Okay. yeah, I've also not used break except for those cases. Yes, so this is an addition to what I already know. Thank you. All right, so I guess I'll just be leaving the remaining questions with Mr. David and see if he would help us put them up on the repo so that we can use them for practice. I guess some of us don't want to practice here in front of everybody, so it's fine to take it and do it privately. It's very fine. It's okay. All right. So thank you so much for being a part of the session up until now. I think we can unmute our mics to say bye to each other.
Thank you so much, Leslie.
Thank you so much. Wilfred, I would like to, please.
Thank you very much. God bless you.
Amen. Please identify yourself, Wilfred and Dixon, on the WhatsApp group. I don't even know who you guys are on the group. It would be cool to connect.
We are anonymous.
Wow. It would be nice to connect. All right. Thank you so much, everybody. Good night.
Good night.
Good night.